Hey everyone, it's Tony with Hidden Light Photography. In the last video, we captured light from over 10 billion light years away. And as we saw, a faint little dot represents something much, much bigger. And today, we're going to be processing that data that we captured. So if you haven't done so yet, hit that subscribe button. I don't want you to miss out on any future content. Now let's jump in and breathe some life into that faint little dot. In part 1, we captured the ancient light that left TON 618's quasar nearly 10.4 billion years ago. And today, we're going to be breathing life into that ancient light. Now, here I have all of my channels: luminance, red, green, and blue. Now this image was captured using my Skywatcher 200p OTA, ASI 2600 mm monochrome camera, and my Optolong LRGB filters. Now the first thing that I'm going to do here is make sure that I'm nice and organized. In other words, I'm going to name each channel for what it is. We have luminance, we have red, we have green, and we have blue. I'm going to do a quick auto stretch on each of the channels, and then I'm going to minimize them. Now, as always, when we're processing an image, we want to start with the corrective work first. That sets the stage for stretching and finally beautification. Now to get started here, what I'm going to do is go into Script, HLP, Astro Image Primer. Now in Astro Image Primer, we'll notice a few options here. We are working with individual channels from a monochrome camera, so we want to select Use Individual Channels. We also want to keep the channels separated so we can inspect them and make sure that we don't need any further corrective action before combining them. Also, being individual channels from a monochrome camera, we want to make sure to perform star alignment. This is going to ensure that once we combine everything, all of the channels match perfectly. Now, you'll notice that I did not select star correction. And the reason is, if you run star correction on the individual channels, you can inhibit the star colors. And I have a video going over that, which I'll have linked in the description of this video here. So if you're curious as to what I mean, make sure to check out that video. And as always, don't hesitate to ask. Next, I'm going to go ahead and select my red channel in the red dropdown, green in green, and blue in blue. Now we can go ahead and measure channel mean values. And what this is going to do is give us the mean values of each channel, which can help us decide what we want to use as the reference channel for linear fit. Now, in the sake of this image here of TON 618, it is basically a star field. There's not any kind of dim areas or bright areas that I want to, keep in check or boost, but there is one thing that I'm going to use to determine what I use. TON 618 generally shows up as blue or kind of purplish, just depending on how it was captured and or processed. In this case, blue is already my most prominent channel, and with how faint TON 618 is, I don't want to hurt that. So I'm going to use highest mean, which in this case is blue, in order to help with bringing TON 618 out more. I'm going to go ahead and click execute, and Astro Image Primer will go ahead and run star alignment and then perform linear fit using the blue channel as the reference channel. I'm going to go ahead and exit out of Astro Image Primer. And here we see that green and blue were the registered channels from star alignment. We also know that they were touched by astro image primer because we have the astro image primer prefix in the image window name. Now we can go ahead and actually delete our original green and blue channels since we won't use them anymore. And if we open up red, we can see the astro image primer prefix in the image window name. Let's do a quick auto stretch on each of our channels. And one other thing that we can notice is that star alignment was completed because we see the hard cutoff line where star alignment aligned each of the images. Red was used as the reference, so we don't see any hard cutoff lines. Next, we have one more channel that we're going to be working with. So we also need to perform star alignment on luminance. Let's go ahead and minimize our red, green, and blue channels. Let's move them off to the side. We'll do a quick alignment of our icons. And what we're going to do is go into Process, All Processes, and come down to Star Alignment. For reference image, we're going to use red since that's what Astro Image Primer used. We want to make sure that View is selected in this little drop down. We don't want to use File since the reference image is on the workspace. We want View. We'll click the icon and select red from the drop down. Click OK. And in target images, again, luminance is going to be the target image and it's on the workspace. So we'll click Views, check Lum or whatever you have your luminance channel named, click OK, and click the circle. So now luminance is also star aligned, and this is going to ensure that all 4 of our channels combine perfectly. We'll exit out of star alignment, exit out of the console, and we'll do a quick auto stretch. Now what we can do is delete our original luminance image since we're not going to be using it anymore. And next we need to crop our images. What I like to do in a case like this is find the image that has the absolute worst hard cutoff. I want the worst one and the second worst one. So if we open up red, we already know that red was used as reference, so there's no hard cutoff lines. But if we open up green, we see a very small cutoff line on the right side. And if we open up blue, we see a very hard cutoff line on the right side. Now, keep in mind, the cutoff line doesn't necessarily have to be left or right. It can be top, bottom, top and right, whichever combination it is, you want the first and the second worst cutoffs. How we're going to use that, let's bring luminance front and center. Let's go into Process, All Processes, and come down to Dynamic Crop. We're going to draw a cropping box in luminance. And then what we want to do here, we have our second worst image, which is going to be blue. If we take blue and we overlap it, if you look at the left side, you can see one, the cropping box for luminance is more than taking away the hard cutoff line. But if we look at the right side, if we watch our cutoff line on blue and we bring it in line with luminance, we can see that the cutoff line is more than taken away by the cropping box in luminance. So now we know that our cutoff lines are going to be eliminated. So we can go ahead and minimize blue. Let's zoom into luminance and let's make sure that we have our cropping box where we want it. In other words, it's going to eliminate any and all stacking artifacts, and it also, puts the cropping box where we want it. In other words, we have this bright star here, and I really don't want to cut it off halfway in, but I also know that I have another bright star up here. So I do have room. If we take a look at my cursor over the cropping box, we see how it changes. I can grab that cropping box and move it in if I wanted. This is now giving me enough room to kind of crop out or keep this entire star, but also down here, I'm not so far into the star. So this is personal preference at this point, but what you want to make sure of is that all of your stacking artifacts are gone and that all of your hard cutoff lines due to star alignment are gone. Once you're done double checking and ensuring that everything is cropped correctly, what we're going to do is open up each of our images. We're not going to click this green check mark yet. We're going to open up each channel, triangle, drag and drop onto each of the channels, red, green, and blue. This little box over here is just stating that we're going to lose our astrometric solution if we continue. That's okay. I'm going to show you how to reinstate that in a little bit. We'll just click yes, and we see how dynamic crop cropped our red channel. Let's minimize red, open up green, triangle, drag and drop, minimize green, open up blue, triangle, drag and drop. We'll minimize blue, and now we're left with luminance. At this point, we can click the green check mark. Now, every single channel has been cropped identical to each other. We're going to go ahead and exit out of dynamic crop. And what we can do here is set our geometry. In other words, orientate the image the way that we want it. Now, ton 618 is a star field, so orientation doesn't matter too much, but this galaxy in the bottom right quadrant, when I was first imaging it, that galaxy was in the top left quadrant. So I want to orientate the image so our galaxy is back up in the top left quadrant. And there's an easy way to do that for all of the images. If we go into Process, All Processes, and we come down to Fast Rotation, here we see a set of different options for rotation. In this case, rotate 180 degrees will work perfectly. If I take the triangle, drag it onto the workspace, and close out a fast rotation, that leaves me with a fast rotation icon. I could take that icon and drop it onto each image, and it rotates it for me. Let's go ahead and minimize luminance. Let's open up red, drop the icon, green, drop the icon, and blue, drop the icon. Now we are completely rotated and orientated the way we want it. Let's exit out of the fast rotation icon. And next, we have the option of running background extraction. Now, as I mentioned in the Astro Image Primer section, if we're going to be running background extraction, we need to make sure that we prepare the stars. In other words, if we're going to be running background extraction, we do want to run blur exterminators correct only, as any issues with the stars can inhibit background extraction's effectiveness. At the same time, we don't want to run correct only on the individual channels, as that can hurt the star colors. So, make sure to check out the video in the description of this video here. I go over what happens as well as the workaround. Also, again, if you have any questions, don't hesitate to ask. I'm more than happy to answer. For this particular image here, we can see that the background is relatively smooth already. Generally, when it comes to monochrome imaging, your background can be different between red, green, blue, HA, S2, O3, and you want to run background extraction on those individual channels before combining them. In this particular case, the background between them is already relatively smooth, so I'm comfortable combining these images as is and then moving on from there. So that's exactly what we're going to do here. Let's go ahead and re-minimize everything. Let's go into Process, All Processes, Channel Combination. I'm going to go ahead and drag red to red, green to green, and blue to blue. And then I'm going to go ahead and click the circle. I'm going to exit out of channel combination and do a quick auto stretch. Now, what we see here is there is a little bit of a gradient going from top left to bottom right. Since it wasn't that pronounced in the individual channels, that's why I opted to just combine them first. Now we can see this gradient, so I'm going to go ahead and run background extraction. First, I do need to run correct only on the stars so I can get the maximum benefit from background extraction. Since the channels are already combined, it is safe to run correct only. So I'm going to go into Process, All Processes, and come down to Blur Exterminator. Make sure that correct only is checked, triangle, drag and drop. Now the stars have the initial correction done. We're going to exit out of Blur Exterminator, exit out of the console, and to extract the background, I'm going to go to Script, SETI Astro, Automatic DBE. Now, Automatic DBE does very, very well on default settings, so I'm just going to go ahead and click Execute. And I'll have a link to SETI Astro's website in the description of this video here. I always encourage check out his videos going over his scripts. He does a very good job explaining how they work, what to do, and if you have any questions, make sure to check out those videos. I'm going to go ahead and exit out of the background model. I'm going to do a quick auto stretch, exit out of the console, and now we can see that the background is much, much more even. Just for the time being, I'm going to go ahead and minimize our original combined image and then continue working on our background extracted image. Now we can see the stars have a lot of kind of blue, purple. That's okay. The one thing that does kind of concern me here, and I'm not sure if the video can pick it up, but there is a little bit of a bluish hue in the background here. And that sometimes happens, especially on monochrome. Everything is imaged individually, unlike a one-shot color where everything is imaged at the same time. And that's okay. Let's go into Process, All Processes, and let's come down to Statistics. Let's go ahead and choose our current image, image 16_ADBE. And here for red, we can see 224.673, green is 224.399, and blue is 227.518. That's going to kind of be where our issue is. Now, I'm not so much concerned about the star colors. That's what SPCC is for. What I'm concerned about is that bluish tint in the background. And the way I'm going to correct for that, over at my cursor underneath workspace, we see this little icon. I'm going to click on that, and that allows me to open up a preview. I'm going to go to some nice blank background, and I'm going to set a preview. Then what I'm going to do is go into Process, All Processes, and come down to Background Neutralization. Always make sure to reset your processes just in case you have anything residual from a previous project. I'm going to click Region of Interest from Preview, and then in the drop-down, I'm going to select the preview that I just opened. Click OK, triangle, drag and drop. Now what that did is neutralize the background. So now we're working on a freshly extracted background and a neutralized background. I'm going to exit out of background neutralization. For a moment, I'm just going to leave the preview up because now it's time to run SPCC and we need a preview for that. However, first, since we got rid of the astrometric solution earlier through cropping and rotation, we need to reinstate that astrometric solution so SPCC can use it. We're going to go into Script, Astrometry, Image Solver. Now, TON 618 generally isn't listed in too many catalogs, and that's okay. I'm sure it's going to be listed here, but what I want to show you, since I have the opportunity to show you now, all that image solver cares about is the right ascension and declination. And we already have that information in here. Now, if you saw part 1, the right ascension and declination numbers don't 100% match what we put into Nina. And that's going to be these last numbers over here. That's the part that's a little bit different, and that's okay. All we need to be is just within a certain tolerance of the center of the image. And we are. We're well within that. We have our right ascension declination. That's going to be very, very usable here. Our date and time is good. Our pixel size and our focal distance is good. Everything is looking good. So from here, we don't need to go into search and then search our target. As long as your right ascension and declination is good and at a close enough range so that then image solver can find it. We're going to click OK, and image solver is going to go ahead and plate solve the image, which then will tell SPCC exactly where in the sky this was taken. I'm going to exit out of the console, go into Process All Processes, come down to Spectrophotometric Color Calibration, or SPCC. I'm going to reset SPCC, and if you need help with SPCC, whether it be using it, how to set it up, how to create these filters, I do have a couple of videos going over that, which I'll have linked in the description of this video here, so make sure to check those out. And as always, if you have questions, don't hesitate to ask. Basically, what we're going to do is choose our sensor, choose the filters that we used, and then we're going to check region of interest from preview. And we're going to select the preview that we already opened up in the previous step. Click OK, triangle, drag and drop. We're going to exit out of SPCC, exit out of the console, go to preview, delete all, which will get rid of the preview that we had, do a quick auto stretch, and we are now color calibrated. So now we're ready to stretch this image. And the way that we're going to do this, generally I'll use SETI Astro statistical stretch, and it works amazing. On this particular image, however, I do want a little bit more control over the stretch, so I'm going to use GHS, or generalized hyperbolic stretch. Now I do have a video going over GHS, and I'll have a link to that in the description of this video here. So if you have any questions, make sure to watch that video and also make sure to ask. I will, however, explain what I'm doing as I'm going. I'm going to go into Process All Processes, Generalized Hyperbolic Stretch. And what I'm going to do here, the first thing that I want to do is over at my cursor at the top right is this little icon. I'm going to click on that, which is going to disable the auto stretch that's currently on the image. Next, over in GHS, we have this little plus sign and minus sign near the top right. If we click on the plus sign, we can now see our histogram curve. Now, one thing that I go over in my GHS video, if your histogram curve is really far to the right, we do want to pull that to the left. I like where this is at currently, so I'm just going to leave it. So now, to get started with GHS, before we make our first stretch, we want to set the symmetry point. The bottom half of GHS, you'll see symmetry point. Where do we get that number from? If we go over onto the image, click and hold, we see X, Y, R, G, and B. The R value currently 0.0013. We want to find the lowest number. So I see 1, 2, 1, 1 was over there. Let's see here. So I think 1, 1 might be the winner. You don't have to spend too much time searching, but you want to get as low as possible. So I'm going to use 0.0011. If I go back over to the histogram curve, grab the caret and move it. Now, take a look at symmetry point at the bottom half of GHS. Watch these little numbers over by my cursor. As I move the symmetry point caret, those numbers change. What we want is 0.0011. And here we have 0.001104. We can go ahead and click and then backspace that 4 out. And our symmetry point is now set. The next thing we want to do is over in the top right, click the minus sign. This is going to allow us to see what we're doing with the curve. Next, we'll open up a preview with the little circle, and we'll grab our stretch factor on the bottom half of GHS, grab the slider and pull it right. Here, we can see our image coming to life. I'm going to grab local intensity and drag it just a little bit. And I like the way that's looking. So what I'm going to do is, just for the sake of this video, is accept that stretch, reset GHS, and next what I want to do is, since this is a star field, there's not really that much that we can do with contrast. However, we do have this nice little galaxy in the upper left quadrant. If I hold Control and draw a little box, I can highlight that galaxy. Not highlight it, but zoom in on it. Now, take a look at the histogram curve in GHS. If I click in the preview and hold, we see this little dancing vertical yellow line. What we want to do is find an area that places that little vertical yellow line to the right of the histogram. If we go into the dimmer areas of the galaxy, right where I'm at, that is perfect. We're right at the far right of the histogram curve. We're going to drag the caret just below that line, and we're going to go to stretch factor and pull it just a little bit, not a whole lot. Local intensity, I'm going to move that left to darken it back up just a little bit. And it's okay to have a negative number in local intensity. If you've used GHS before or watched other tutorials, some people say do not have a negative number. Others say have a negative number. I have not found any negative impact on having a negative number. All that we're looking for is the image to look good. Now, if we click the little preview button again, that little circle in GHS, we have before. Notice how here the preview window says real-time preview. If we click the circle again, we have real-time preview with generalized hyperbolic stretch. In other words, before and after. Before and after. We have a nice contrast boost with that galaxy. Now in the preview window, bottom left corner, we'll click the icon, give us a full view of the image. Before and after. That's looking good. I'm going to click the square to accept, reset, and let's take a look at ton 618. Here we have ton 618 coming out nicely. What I want to do though is kind of get this little galaxy on its side and just see how that's coming out. I want to go just to the left of the histogram peak. So I'm just going to click to bring my vertical yellow line out, grab my symmetry point slider, line it up. Now I do know that you can click send to SP and that'll send where your vertical slider is to the symmetry point to set the value. I just like grabbing the caret and dragging it under. I don't really know why. It's just how I like doing it. But now that my symmetry point is set for this last stretch, I'm going to go to stretch factor and I'm going to pull that right. I'm going to move local intensity a little bit left and then protect highlights. I'm also going to bring that down as well. And this is just, you're just stretching to how you like it. That is all that this is doing, is bringing it exactly how you like it and until the image looks good to you. GHS just gives you a whole lot more control And that is just what I want for the TON 618 image. For the sake of the video, I'm going to accept that stretch, reset GHS, and let's go ahead and exit out of the preview. And let's take a look around. Let's make sure everything is looking the way we want it. TON 618 is looking good. Our galaxy is looking decent. So I like the way that this image is turning out. Now, one thing that we could do here is maybe darken up the background a little bit, but you don't want to overdo that. I'm liking the way that this background looks, but if you ever wanted to darken it up, I'm going to show you how to do that. Let's open up a preview. And if we go to transformation type and we go to linear, black point, we take that black point slider, move it right, and we can really set the background the way that we want it. So what I'm going to do, I might actually, let's go before and after. I might actually accept this the way that it is. I'm going to click the square, reset GHS, and I'm going to leave this image the way it is. Let's exit out of GHS. We'll minimize our stretched image for the time being. Move it off to the side. And now we're ready to process luminance. So I'm going to open up luminance, and we're at the point where we need to run star correction on the stars, and then we need to extract the background. I do see just a very slight uneven illumination throughout the image, mainly in the corners here, but it's kind of a weird pattern, but we're going to extract the background, make sure everything is nice and even. So what we're going to do is go into process all processes, come down to blur exterminator, make sure correct only is selected, triangle, drag and drop. So now I'm going to exit out of blur exterminator, exit out of the console, go into script, SETI Astro, automatic DBE. Again, automatic DBE does amazing on default settings. So I'm just going to go ahead and click execute. I'm going to exit out of the background model, do a quick auto stretch, and we are ready to move on. I'm going to go ahead and exit out of the original luminance image and then continue on with what we have here. So now we're at the point where we can stretch our luminance image. Again, what I'm going to do is use GHS. So I'm going to go into process, all processes, and come down to generalized hyperbolic stretch. I'm going to go ahead and delete the automatic stretch that's applied. And then I'm going to click in the image and then find my lowest value. Now, here you can see that luminance is very bright. We have a K value. Now this is a grayscale image, so we have our K value, and our K value is 0.0724. If we were to go into GHS, click our little plus sign, we can see that our histogram curve is more off to the right. So this is exactly what I was talking about earlier. Now to correct for that, I'm going to go into transformation type, click linear, and we don't have our caret off to the left here that we can use to drag. I'm going to grab our little slider, move to the left, and our caret appears. Let's go just a little bit at a time. So I'm going to drag our caret to the right, and I'm going to click accept, reset, and let's recheck. So now we are 0.0701. Let's go into linear, grab our caret, drag it, click accept, reset, and we are 0.0679. Now let's go back over and click our minus sign, Let's click the plus sign and just kind of double check where we're at. So we're slowly starting to move left. So let's go ahead and redo our linear. Let's pull the caret to the right, accept. Let's check out where our curve is, which we're right over here now. Let's recheck our values, 0.648. Let's go to linear. We can now see our caret. Let's drag it right, just a little bit at a time. Let's reset. (0.262). So I'm gonna run this the way it is. Let's reset. And now let's find our starting symmetry point. So I'm gonna look for the lowest value. So we had 0.0239. Let's go in here. Let's just kind of check it out. We don't want to spend too much time on this just for the sake of the video. Let's go ahead and 0.0239. So we're gonna go ahead and use that, and we're gonna click, make sure that we're fully zoomed out. And then we're gonna grab our stretch factor, and we're gonna stretch our luminance image. And always make sure you have a preview open so you can see what you're doing. So let's go ahead and do this with a preview. 0.0239. Our preview's open. We're zoomed all the way out on our histogram. And let's give this a stretch. Let's go ahead and adjust local intensity. Let's protect highlights. And now one thing that I want to point out here, this is why we want to make sure that we're not too far right on the histogram. For the sake of the video though, we're going to go ahead and use this. Let's go ahead and apply, reset. And then what we can do here is go into linear. And now we can use our black point slider and do a fine-tune adjustment on this. We'll accept. The reason that you can't use the black point slider to begin with, it moves way too fast. You have to use the caret to start with. Once you do your initial stretch, the black point slider becomes a lot easier to use. So let's go ahead and zoom in on our galaxy, and let's find an area here that goes just to the right of the curve, which looks pretty good now. Let's bring our caret over to the vertical yellow bar, and let's grab our stretch factor and just a little bit. We'll move our local intensity down a little bit, and I'm liking that contrast adjustment. Let's accept, reset. Let's check out ton 618. Looking good. Let's do one more stretch here, just to the left of the peak. Grab our symmetry point caret. Do a nice little stretch here. Move local intensity in. Protect highlights in. Before and after. So I think we're good there. Let's accept, reset. Now, one thing I want to point out here. You probably noticed that I have statistics open. Right now, our statistics is on our RGB image, and we can see that we are about 9,300 on ADU. Our luminance, however, is at 9,380. So we are actually looking pretty good. We can combine this and not worry about any intensive background issues. However, if our mean value for luminance was way high, let's say 10,000, 11,000, we can adjust in GHS using linear. We can pull the black point slider right and darken luminance and watch our mean value drop as we accept the stretches. On the flip side, if luminance was way too dark, in other words, right now luminance was, let's just pretend 6,000, and we want it at 9380, we can move the black point slider left and brighten luminance up. So right now, we're actually looking pretty good at 9380. In fact, what I might end up doing, let's go ahead and do just a little tick mark to the right here. And let's accept that. And we can see that we're now 8813. We're a little bit too dim. So let's go ahead and bring that back up. Just a little bit. So 9374. So this is going to go ahead and combine nice. Let's exit out of GHS, exit out of the preview. We now have our stretched luminance image, but before I combine it, I want to add a little bit of detail. Let's go into Script, HLP, Astro Image Detail. Let's do our zoom as a 1:1, show preview. And then what this is going to do is show us exactly what the script is going to do to our image. What I want to look at is the galaxy here. Now, the galaxy is very, very small in the field of view. So there's not that much detail to resolve. This is a lot of astrophotography is less is more, right? You don't want to go too heavy on a lot of these things. I'm going to get rid of small scale structure. I'm going to lower large scale structure all the way down. Let's refresh. And that actually looks pretty good. In fact, let's go ahead and get rid of it. Let's refresh, and that's what it looked like before. Let's pull this up just a little bit, refresh. Gives it just a little bit of pop. That's good. I'm going to execute. And now we have some detail put in there. Now what we're going to do here, here's our stretched RGB image, and we're going to go ahead and combine them. First, what we want to do is, let's reduce some noise. Let's take a look at luminance. Luminance is actually looking very, very clean. I like that. So luminance is looking good. RGB, however, is quite noisy. So let's go to Process, All Processes, and let's come into Noise Exterminator. I'm going to go ahead and start off with 0.7. The noise isn't that extreme. So I think 0.7 should bring us to a nice little middle ground. So I'm going to go ahead, drag the triangle onto the image. Noise Exterminator is going to do its thing, and then we'll see where we're at. Also, on a side note, I had quite a few comments earlier about upgrading to Noise Exterminator version 3. Amazing. I am loving Noise Exterminator version 3. It does an absolute amazing job. In fact, here we are, not even that big of a setting. The noise is just taken care of just flawlessly. If we go before and after, it did not get rid of any details within the galaxy. This is just amazing. I love it. So noise is taken care of. So let's get out of Noise Exterminator. Let's go to Process, All Processes. And if I don't accidentally click, we can get to where we're going. LRGB combination. We're going to get rid of R, G, and B. All we're going to leave checked is going to be L. I'm going to minimize luminance for a moment, drag the icon into L, and let's go ahead, let's just zoom into this galaxy really quick because I love this transformation. Triangle, drag and drop, and this is going to combine luminance with our RGB image. Now what we can do here is, let's take a look at ton 618, before luminance, after. It just tightens it up. It gives it some pop. You can't really get pop on a point source, but in the galaxy here, before, after, before, after. So what we're going to do now is let's give this some color. We're going to go into process, all processes, come down to curves transformation. And really the contrast is good, so we don't need RGB/K. The only thing that we're going to be working with is saturation. Let's open up a preview. Let's click saturation. And what we want to do, let's hold control. Let's go into ton 618. And let's go ahead and give it a little bit of a boost in saturation. Not too much. Now keep in mind, the color data that I have is only 30 minutes per filter, so there's not a lot to resolve. Let's go ahead and accept. Let's reset. And our stronger colors, such as the star over here, that's going to show a lot more. So more integration time would really help this image out. But for the time being, this is what we have to work with. So let's do one more little bump on the color. We have before and after, and we don't want to overdo it, but all I'm trying to do is just try to get ton 618 to pop more. But let's go ahead and reset, and we have our final image. So I hope you found this video useful, and if you did and want to help support the channel, check out that join button and consider joining a Hidden Light Photography membership. There's lots of perks in it for you, and your support helps me bring you more content. Another way you can help support the channel is checking out my High Point Scientific affiliate link if you're in the market for some new gear. It doesn't cost you anything extra, and the support helps me keep the channel growing. Also, do me a favor. That channel icon that popped up, hit that channel icon and subscribe. I don't want you to miss out on any future content. Drop a comment in the comment section. Have you processed anything extremely faint? What obstacles did you run into? And then check out that next video. Until the next time, clear skies.